We've already seen that if we configure an enable secret password for our router, it's not going to appear in plain text in our running config. Let's do a show run, and here's the enable secret hash. This is an MD5 hash, not very readable, and because it's a hash value, that means it's essentially a fingerprint. It's going to be a 128-bit value no matter how long the password was. And as a result, although I could run a brute force attack against that password, I'm not going to be able to just plug it into some sort of algorithm and immediately decrypt the password. The reason I bring that up is that there's another way to scramble up our passwords inside of our running configuration. For example, let's go down and take a look at the line configuration, show run, pipe to section line. And let's say that I wanted to set up a password for my VTY lines. Let's get into global configuration mode with the configure terminal, and I'll say line VTY 04, and I'll say password Cisco. If we now look at that line configuration, we see that the password is in clear text. If somebody's looking over my shoulder, they're doing some shoulder surfing, or just walking by, they could easily see that the password is Cisco. If we want to scramble that up, there's a way to do it. We can enable the password encryption service. However, this is weak encryption. There are multiple utilities out on the internet that allow you to take the encrypted string, you put them into these utilities, and they immediately tell you what the password is. So please understand, this is not meant to be super strong encryption. This is going to prevent the casual observer from seeing what your password is. Here's how we turn on that service. Let's go into global configuration mode, and we'll say service password-encryption. Now when we look at our line configuration with the show run pipe to section line, we see that password is using type 7 encryption, which is weak encryption, by the way, but it's this alphanumeric string. And if somebody were walking behind me and they saw that string, they probably would not know that that string could be decrypted into the word Cisco. But if someone did get possession of that string, it would be super easy for them to determine what the password was. To illustrate this, even without having some pre-installed piece of software, I just now did an internet search for Cisco password cracker. And the first result I got on my search was a web page that allowed me to paste in this string and see the decryption of it. Let's illustrate how easy this is. I'm going to select this. I'm going to copy from my terminal emulator. Let's go over to that website now. And this is not a website I ever remember using before or ever seeing before. It was just the first hit in this internet search. Let's paste in this type 7 password, and let's see how quickly we can crack it. Crack password, wow, how easy was that? It immediately tells us that the plain text of that password is Cisco. And the question might be, should we be overly concerned about this? Well, probably not if we use good practices, because remember, to even get in and look at the running configuration, we have to be in privilege mode. Somebody would have to have already provided the enable secret password, so hopefully we have one of those set up, or we could even take it a step further and require a username password combination. And as another good practice, we could have set our exec timeout that we've previously discussed that will log us out after a certain period of inactivity. So if we're following those good practices, having security barriers preventing someone from seeing this running configuration in the first place, then it's probably not a huge concern that the type 7 password is not particularly strong, because again, the main purpose of this is to prevent the shoulder surfers from just casually observing the password, and it's done that job well. In this video, we're going to see how to assign an IP version 4 address to an interface. And we can assign an IP version 4 address to a variety of interface types, maybe a serial interface, a loopback interface. We're going to assign an IP address to an Ethernet interface in this example. Before we get going, we can do a quick show IP interface brief just to see what interfaces we have and what IP addresses may already be assigned to those interfaces. We're going to take a look at assigning an IP address to Fast Ethernet 0/0. This is in its default condition. In other words, it's administratively shut down. So in addition to assigning an IP address, we might want to administratively bring up this interface. Let's go into global configuration mode, and now to assign an IP address, we don't do that in global configuration mode on our router. We're going to go into interface configuration mode. I'm going to say interface followed by the interface identifier. And instead of typing out Fast Ethernet, as long as I give enough characters to make that interface type unique, FA should do it, then I can use that as a shortcut. I'll say FA, short for Fast Ethernet, 0/0. Notice what happens to my prompt. Right now, I'm in config mode, but once I press enter, I've now moved into interface config or interface configuration mode. Now, it's not just config, it's config-if. Now I can assign an IP address to this interface. To do that, we say IP address, and I give the IP address for this interface. Let's say it's 172.16.1.1, but that's not enough information, is it? We also need to say what is the subnet mask, because we've got 32 bits worth of addressing here. We have to draw that dividing line to say which portion of this IP address refers to the network and which portion refers to the host. We're going to use a 24-bit subnet mask, and even though it's common for us to use slash notation when we're writing out an IP address or a network, notice that, if I use context-sensitive help, notice that slash notation is not supported. I would not be able to say IP address 172.16.1.1/24. Instead, I need to put in the subnet mask in dotted decimal notation. No problem, we'll do that. We'll say 255.255.255.0. That is a 24-bit subnet mask. And usually here we would press enter to say that this is the IP address. But just for completion's sake, I want to make you aware, and I'll show you this with some more context-sensitive help, I want to make you aware that we could use the secondary keyword here. There have been a couple of times where I've found this useful. Usually you'll not use that word, but if for some reason you need a single interface to belong to more than one subnet, you could do that. You could assign two different IP addresses and two different subnets. You just give the keyword of secondary after one of those. Generally, we're not going to be doing that though. Just wanted to make you aware of it. Generally, we're just going to say IP address, give the IP address, give the subnet mask, and press enter. Remember, by default, this interface is administratively shut down. Here's how we bring it up. We do no space shutdown, and we're done. We can say end to exit out, and let's do a show IP interface brief right now. And we see that Fast Ethernet 0/0 now has an IP address. I don't have anything connected to this Fast Ethernet interface. This is not connected into a switch, so you'll notice that I'm up at the physical layer, but I'm down at the data link layer. This is what we would expect to see on a Fast Ethernet interface that's administratively up, but not connected to anything.